Alright, and welcome back to video 3 of Who Knows? Who knows how many it's going to be? Right, where were we up to? Well, I realised just as I finished that video that I actually didn't show you the balance method for that example 2. So let me just quickly show you that. So we had 3x add 5 equals 29. Now, if you remember at the end of that video, what we did was we had a bar which was 3x and 5, and then a bar which was 29. And we took 5 off of both bars, like we literally chopped them off. And that left us with 3x and 24, which we could then divide both of those by 3 to get our final answer. How do we solve this? How do we write it down without drawing the bars? Well, let's have a look. What we want is we want the number of x's, so these x terms, we want those by themselves at the end so that we can just divide. We just do a division at the end. That's the aim with this sort of equation. So the 3x is over on the left hand side of the equal sign at the moment, but it's got a plus 5 next to it. It doesn't want that there. So we're going to take that away. And I can't just take it away from the left hand side. I've got to take it away from the right hand side as well. So remember, we've got the left of the equal sign, we've got the right of the equal sign. So I talk about the left hand side and the right hand side. And of course, at all stages, I've got to do the same thing to both sides. Now, what you've got to remember is, I'm literally writing this take away 5 underneath the plus 5. They are going to cancel out. If you think back to the picture, it's literally being chopped off and gotten rid of. It's not there anymore. But the 3x still is there. So I'm still left with the 3x. 29 take away 5, that's 24. And now we're at this stage where it's quite a comfortable stage to be at, because we are very confident at going, oh yes, I'm going to divide both sides by 3. So divide by 3, divide by 3. And, you know, if you're not confident on 24 divided by 3, which, you know, you might, it could be, or certainly if it was a harder question, you can always use a calculator. You can always use the bus stop method. So this is going to be x. And then 24 divided by 3 is equal to 8. And then this is me solving that equation, but without drawing any bars. Right. Let's look at one more example. So I'm going to do a trickier example, which will not even really be answered yet, but I want to show you how powerful the bar method is for more complicated questions. So imagine I have 7x plus 2 is 3x add 12. So this is a more complicated looking equation straight away. For the record, we're not going to be answering questions like this in task 178 or 179. I'm just using this one example here to show you the bar method where we've got x's on both sides. So I will come back to this. So I draw 2 bars. And what I do is, clearly on this first one, I'm going to split it into 2. And where I put this line, if this is 7x, then whereabouts should I put the line for this one? Should it go on that side or should it go on that side? Like, whereabouts should it go? It should go on this side, because I'm going to, well, I'm going to, you know, certainly make the assumption that 3x is less than 7x. I mean, it might actually not be, but I can certainly use the fact that 3 is less than 7. So I'm going to write 7x and 2, and I'm going to have 3x and 12. And again, I will repeat, it doesn't actually matter where I put these lines, but I'm going to put them in a kind of a sensible place where, yes, I can get rid of 3x easily, where I'll still have a little bit of room here. So I'm just gonna use the fact that 3 is less than 7 and draw it over here. So anyway, hopefully everyone is okay with why I've drawn this line over on this side. It's because the 3x literally has to be smaller than the 7x because there's less of them. So let's deal with the numbers first, because that's what we were doing in the other ones. So the number terms. So I'm going to chop off this 2, basically. And it's clearly not drawn to scale, is it? Because that 2 is really rather big. And it's chopping off this part of the 12. It's not drawn to scale. That is clearly actually too big. But it doesn't matter. It's just a rough sketch. It is not drawn to scale. The question is this little bit here, which was part of the 12, but now we've chopped off 2, what's going to be there? I know it's not the right size. I could draw it again and make it more of a true scale. But the idea is I'm trying to do this quickly. What goes in there? It's not 12 anymore. It's 10. It's 10. Because I have literally chopped off the 2, chopped off that 2. 12 take away 2 is 10. So this bit here is 10. Now, there's another thing to deal with now. The x's. There is something that I can cancel. There is something that I can chop off. Both of these. Maybe you can spot it. It's the 3x. If you chop off that 3x, you chop it off from here. Again, clearly it's not drawn to scale. It's too big in comparison. But that doesn't matter, because we know what 7x take away 3x is. It's 4x. That's what you're left with. So the equation actually simplifies down to 4x equals 10. So what do you do now? Well, you divide both sides by 4. So you get x equals... So 10 quarters is actually what we have. So 4 doesn't actually go into 10 a whole number of times. Now that's okay, because sometimes we can get decimal answers, or we could leave them as a fraction. In this situation, what I would probably do, or what you really should do, is simplify that. So 10 quarters is the same as 5 over 2. I'm going to divide top and bottom by 2. So I could actually leave this as my final answer if I wanted an improper fraction. If I wanted a mixed number, how many 2's go into 5 is 2 with 1 left over, and the denominator stays the same. So it's 2.5 as a mixed number, and of course that's 2.5 as a decimal. At this stage, by the way, we could also use a calculator. So I could have just done 10 over 4 straight away, press the SD button, and there you go, you get 2.5. So that's just an example, and we will look at that in more detail in future videos. Okay, so what I'm going to do is give you a few, well, maybe 2 or 3, I think probably 3 equations to have a go at. Again, before I even start Hegarty, because realistically, this is what would, I mean, not exactly structured in this way, clearly, because this is a video, but we would have done some examples, and, you know, you would have had a go, then I would have gone through them, and then you would have been set off on some questions. So this is what's going to happen here. Okay, so number 1, can you solve, and it would be great if you could draw the bars, x plus 12 equals 17. Number 2, 2x plus 5 is 19. And number 3, 5x plus 14 equals 2x, add, what shall we say, 23. How about that? So pause the video, have a go at these, draw the bars, see if you can get the answer, and then resume the video and I'll go through them. Right, first one. There is x and 12 and 17. I will chop off the 12, leaving me with 5. And that's already nice for us. That's already the answer, basically, isn't it? That's x is 5. Number 2. So there's 2x this time, and 5, and 19. Now what I'm going to do is I'm going to chop off the 5. Now what's that actually going to turn this 19 into? I've not drawn it to scale. It's going to leave it at 14. Right, because 19 take away 5 is 14. So I have 2x equals 14. I now divide both sides by 2 to get x equals 7. And we can check it, right? 2 times 7 is 14. Add 5 is 19. So it works. Right, and then the last one. So what have we got? Put 5x on that side and 14 there. 2x there and 23 here. Now what I'm going to do is I'm going to chop off the 14. So you tend to want to deal with the numbers first. So get rid of that. Get rid of that. Now that 14 is literally gone. We did 14, we took away 14, so it's gone. But this 23 isn't completely gone. There's still part of it left. 23 take away 14 is 9. And then 5x and 2x, I'm going to chop off the 2x. Now that really gets rid of this 2x. It's gone, and I'm just left with the 9. Remember, the number terms and the x terms are separate. But there's still part of this 5x left. It was 5x, but we took away 2x. So we are left with 3x. And so my equation simplifies down to 3x equals 9. Divide both sides by 3 to get the answer of x is 3. And we can actually try that out. 5 times 3 is 15. Add 14 is 29. So on this side, this is when x is 3, I get 29. What do we get on this side? 2 times 3 is 6. Add 23 is also 29. So it works. And that's the idea. Right. I think we are now ready to look at the Hegarty tasks, because the ones that involve subtraction, I think will be okay to talk about without the bars at this point. So let me just move this, and I'm going to press continue quiz. So x add 6 equals 18. So maybe this is one you can do really quickly. If you want to use the bar method, this is a good one to do the bar method on. So x and 6 is 18. So I would chop off the 6, leaving me with 12. Of course, that one we can probably do just by looking. 14 add x equals 16. So don't be put off by the fact that the 14 and the x have swapped round. They're being added up. Doesn't matter what order you add up in. And if I did the bar, just means I could literally put the 14 on that side. There's nothing wrong with that at all. So 14 and x makes 16. So I'll chop off the 14 leaving me with 2, right? Because 16 take away 14 is 2. X add 4 is negative 2. Now, as soon as we start getting negative numbers involved, or as soon as we start taking things away, the bar method becomes a little bit more tricky because it's difficult to visualize how we would draw it with minus numbers. You know, do I draw it going in? Do I draw it in a different color? Is this... It's quite complicated and not something that I particularly want to try to focus on through a video. What I want to do is answer this using now the balance method. Okay, so watch what I do. I'm going to write x add 4 equals negative 2. So negative 2 is just a number, right? It's on the number line. X needs to be by itself. That's ultimately the aim of solving an equation. But at the moment, 4 is being added to it. What would we do to get rid of that plus 4? Well, what we did to get rid of the plus 6 was we took 6 away. What we did to get rid of the plus 14 was to take 14 away. Here I'm going to take away 4 from both sides. The x is still going to be there. Just like in all the other bar method questions. And then here's where I've got to be really careful, right? If I'm on a number line, I'm starting on negative 2, and then I take away 4, I go further down the numbers, I will go down to negative 6. So it might be worth doing a bit of negative number arithmetic revision as well. You know, you could even pause this, do a bit of revision on negative numbers on Hegarty. That's no problem. I'm also happy to do a separate video just on negative number arithmetic. That's not a problem. Right, x take away 2 is negative 5. So let's have a look at that one. X take away 2 is negative 5. So we want the x to be by itself. Now this is the first one we've seen, the first one we've looked at, where it's not a plus anymore on the next to the x. It's a take away. The only difference is I'm going to add 2 instead of take away 2. To get rid of this take away 2, to undo that, I add 2. I basically do the opposite thing, right? When it was add 4, I take away 4. Well, in this question, it started as a take away 2, so I add 2. The point is that the minus 2 will now go up and become 0 if I add 2, so it's gone. What's still there, though? The x is still there. And if I'm on negative 5 and I add 2, I go up the numbers to negative 3. Right, this is a one where, again, it does not matter which way round you write on the equal sign. So if you wanted to, you could actually write this as x minus 7 equals negative 8. There's no problem with swapping round the left-hand side and the right-hand side of an equal sign. There's no problem with that at all. So if you're more comfortable with the x being on the left, not a problem. So I'm going to write it like this. Just because I can. There's no problem with doing that. So we've already seen what do you do to get rid of this take away 7? You add 7. And you got to make sure you do that to both sides. So x is whatever negative 8 add 7 is. So this is again where we have to be really careful. I'm starting down at negative 8 and I'm going up the numbers 7 steps, so I land on negative 1. It's a really common and silly mistake to go, to think the answer might be minus 15, right? That would be negative 8 take away 7, not add 7. Right. this is where I might pause this video because we're already at 20 minutes. But what I might do is I might finish by talking about this. There is nothing different about how we actually answer this question. The reason this question is more tricky is because it has a fraction in it. It has the improper fraction 5/3. So I'm going to finish this video by answering this question, and then we'll see how we start the next one. Okay, we'll see how we start the next one. So x take away 5/3 equals 1. So I would write down the question on a bit of paper. And now, because of the kind of things I've been learning, I know I have to add 5/3 to both sides. So 5/3 is just a number. It's not as nice as a whole number, obviously, but it is just a number written as an improper fraction. It's the answer to 5 divided by 3. So if I wrote it out as a decimal, it would obviously have some numbers after the decimal point, right? It's not a whole number, but it is still a number, and I can add it to both sides. So I'm going to write add 5/3, and I'm going to write add 5/3. So it's a bit strange, but bear with me, because this side is actually really simple now. It's just x. X is still there. I had minus 5/3, but I've added on 5/3, so that's gone. I need to work out what 1 add 5/3 is. Like, that's actually what I need to work out. In this situation, there's like a few options you could go for. You could write that as a mixed number. That's 1 2/3, and if you added another one, you'd have 2 2/3. Like, that's a perfectly reasonable thing to do. I guess if we were being a bit lazy, we could use a calculator, right? We could just type that into the calculator. Hegarty does want it as an improper fraction. So what we're going to do to answer this is to remember how we actually add fractions without a calculator. We need a common denominator whenever we are adding or subtracting fractions. The denominator that we are going to choose is 3, because this fraction over here is already got a 3 as the denominator. How am I going to write the number 1 as a fraction with a 3 on the bottom? Remember, the line in a fraction means divided by. So whatever's going to go on top, when we divide it by 3, has to give us the answer of 1. So the answer is 3/3. 3/3 makes 1 whole, makes the number 1. So instead of writing this 1 as a 1, I'm going to, well, really I'm unsimplifying it. I'm making it more complicated so that I can combine it with the other fraction. I mean, that is literally how you add fractions. Add 5/3. I think I've done well for that to be the first time I actually have to scribble something out. So we should keep a count. So I'm on 1. I'm on 1. So let me actually write this out again. X is 3/3 add 5/3. Now, if you can remember how to add fractions, once the denominator is the same, you're just going to add the tops up, because we are really counting an amount of something. Here I have 3/3. Here I have 5/3. The question is how many thirds do I have altogether? 3 of them, and then another 5 of them is 8 of them. So you are just adding the top numbers together, so long as the bottom numbers are the same, so long as you've got a common denominator. If you don't have a common denominator, remember you need to find one. And it'll be a common multiple of the 2 denominators that you started with. So anyway, how do you actually put a fraction into Hegarty Maths? So you can go on the on-screen keypad, and here you go. I could choose a mixed number. I've just noticed I'm going to have to make myself a bit smaller so you can see this. I shrink down. There you go. Is that all right? Yeah, okay, so there we go. You've got the option of a mixed number here, and you've got the option of just a normal fraction here. And I'm going to put 8 on the top, and I'm going to put 3 on the bottom, and I'm going to press check, and then I'm good to go. Let's just I might skip the next questions, but let's just see what they are, because I actually don't want to go through all of them. So you should be experts on this by now. You should know that one. Maybe you have to work out 21 divided by 7, but still, you should know that that's what you do. So skip that one. So I'm not going to get 100%. I'll have to redo the quiz. I'm only joking, by the way. You don't need to get 100%. You need to maybe get 80 or above. And if you're really struggling, you must send me an email to let me know. Okay? 7x equals 2. 7x equals 2. I think we'll end the video with this one. 7x equals 2. What am I supposed to divide both sides by? Do I divide both sides by 7, or do I divide both sides by 2? Or is it a trick question? Do I choose something else? Well done if you can remember that it's whatever's in front of the x. So divide by 7, divide by 7. Now, let's not worry about this just for now. Let's remember that this is now literally going to be x. And this is actually a fraction. It's 2/7. Before, we were getting answers that we could actually work out. But here, it's almost easier because it's already the answer written for you. Give your answer as a fraction in its simplest form, it says. 2/7 is already a fraction, and it's already in its simplest form. So there you go. So hopefully this has been helpful. I am, of course, making a series of videos, so there will be some more coming up, which is going to help us with the harder and harder questions, where there'll be some division involved, there'll be some more stuff involved, but hopefully you're feeling as though you're making some progress through these videos, and I obviously invite you to make sure that you are able to answer the questions on Hegarty Task 178. Right, leave a like if this has been helpful. Send me an email if you have any questions, and I'll see you in the next video.